Welcome to RCR Wireless News. I'm Martha DeGrasse, and our topic today is Cloud RAN. I'm joined by Monica Paolini. She is founder of Senza Fili Consulting. Monica, thanks for being here.
Thank you for having me, Martha.
And also here is Renuka Bhalerao. She is Senior Product Manager at Radisys Corporation. Renuka, thanks very much for being part of the Hangout today.
Thank you, Martha.
We hear a lot about Cloud RAN today, and we also hear a lot about virtualized RAN. So I think we need to start with a little bit of a definition or an explanation about the difference between these two terms, really. Monica, can you start us off with a little bit of a definition here?
Yeah, I mean, this is actually a very interesting question because when I started working on CRAN and vRAN, I thought of one concept, one model, but really it's much more interesting than that, and much more complex, and there's much more room for differentiation. So there are many ways in which you can move from the current situation where you have the RAN all distributed to the situation where you have the vRAN, which is the sort of the end game. In the vRAN, everything is virtualized. Everything is all the hardware and software. So you get to a point. This is sort of the end game. Is that feasible today? No, but there is a lot of both intermediates and more and other models that are becoming much more popular and will lead us to vRAN. So the CRAN, the initial part, you have a situation where only some elements are virtualized, and there is a different degrees of centralization. So you can look at it in different levels. How much the RAN moves to the center, so how centralized it is, which functions are virtualized and which ones are not. And you can have any combination. And I think that this is what makes CRAN and the vRAN approach very powerful. And so sometimes when you talk to people and they say, well, I don't believe that CRAN is going very far, it's because they only look at one model. And if you look at every model is relatively small because it only applies to some situations. What is interesting to look at in terms of the development of virtualization at the RAN level is the fact that you can do it in different ways. Operators will want to do it in different steps so that they can get comfortable as they go. So the initial part is to have a more limited CRAN deployments, limited in the sense that you do not virtualize everything on day one. That would be very risky and dangerous. There is a little bit like the China Mobile in some markets where you have a greenfield deployment. There is more of a scope for going big on day one because there is no legacy. The more legacy you have, the more careful and the more the more careful you want to be with your transition to CRAN. So what we're seeing is that there are a lot of models, and there is a lot to learn from each of these models, and then to move forward gradually.
Okay, great, thank you. Renuka, what are you seeing in some of your conversations with operators and vendors around Cloud RAN? Is there an interest in going step by step and moving slowly?
Yeah, it's a very good question. So the way Monica explained it, it's architecture shift that the operators are looking forward to. And the architecture shift takes them and makes the network ready to get into the virtualized space where all of the industry is moving. So from their perspective, they would like to see the benefits in a step-by-step approach, but the end goal is to have a complete virtualized space. So yes, they are ready and open to have some use cases and scenarios where they can use some partial cloudification of the RAN and handle current scenarios of adding capacity or adding coverage. And then as we would become comfortable with the concept of the virtualization and have architecture validated, the end goal will be to have a complete virtualized, a complete base station in the cloud.
So you're talking about benefits of adding coverage and capacity. What about cost savings? Is that on operators' minds as well here, or not yet?
Definitely. For all of these scenarios, the goal is going to be to have cost savings, and cloud architecture in general, the shift towards cloud in the network is with that in mind, that is about cost per bit, and it's about saving the cost for not only but also how you maintain the network going forward. So yes, that is being considered, and it's a combination of again taking all the resources and utilizing them in the best possible way, and then also being able to take that cloud architecture which separates out the software from the underlying hardware and eventually gives you many more options, how you manage the sites, to how you pool the resources, to how you take that open architecture of virtualization into consideration. And that eventually does mean saving costs on managing the initial deployments as well as managing how you maintain the network going forward, and take care of any of the in-between steps where you handle interference, if you handle additional capacity, you handle how energy saving will be considered by making use of only the required set of resources at any given point.
Okay, great. Thank you. Monica, what are you hearing about potential cost savings with this centralized RAN or cloud RAN?
Well, what I'm hearing, there's a lot of interest clearly in the sort of short-term savings. So a lot of people, a lot of operators claim that they can get cost savings right away, and that's great news. But I think that what is even more interesting is to really think about in the long term, because this is a long-term process. It's not just as we were talking before. It's not just you move to cRAN over the next year. It's going to require a lot of gradual upgrades, and there is a lot of learning that needs to be made. So I think that we need to look at it in the long term. It's more difficult to quantify, but I think that we need to grasp the potential change, which is going to be even bigger than what we get in the short term. In the short term, what you might see is some cost savings, but also some additional costs due to the fact that you have to learn how to run cRAN, you have to retrain your staff. The operational complexity goes down, but you have to learn how to do this. So in the very short term, you might even see that some of the costs will go up, but I think that it's in the long term that you're going to see the real benefits. And again, they're difficult to quantify, but because cRAN allows you to run the network in a fundamentally different way. And so there is a lot of sort of deep changes that will take place, and I think that that's very important to keep in mind, even though they don't show up in the next couple of years.
Now, you mentioned retraining workers. Can you give a little more specifics there about exactly the types of skill sets that people are going to need to have?
Well, yes. I mean, you have to when you work in a virtualized environment, you no longer have to go and touch the RAN at the very edge. So you tend to do more of the work in the data center. You need to understand how the software works in a virtualized environment, and that's very different because it requires more of an IT type of perspective than a telco type of perspective that the operators are more comfortable with. Everything is more flexible, but the flexibility has a cost in terms of complexity, so you need to learn to deal with the complexity. So it's an opportunity that comes with a little bit of a different way to structure stuff, and that those are the type of things that are sometimes more difficult than technology changes per se.
Well, yeah, we're hearing that operators are actually looking for the words cloud RAN on resumes, so that probably denotes, you're saying, experience in data centers, IT skill sets, IP networking type skill sets? Yeah. Okay, I'd like to move on and talk a little bit about fronthaul, because that's something that is obviously required with this architecture, and it's a challenge. So, Monica, I know that you've done some work in this area and looked at different fronthaul solutions. So, what can you tell us?
Yeah, this is the fronthaul is where most of the worry about the feasibility of cRAN comes about. So a lot of people say, yes, cRAN sounds good, but what about the fronthaul? And so the traditional answer to that is that well, you need fiber to get to the cRAN. If you want to have a cRAN, you need to have fiber, and fiber is not everywhere. On top of that, if you do not have fiber to all the cells, or sorry, if you don't have front haul to all your cells, then the advantage of CRANs is greatly diminished. You need to have all your cells in an area using a CRAN model. So that has been really a key criticism, but I think that we are seeing that this is actually something that can be addressed, because fiber, yes, it remains the preferred front haul solution, and this is because when you do CRAN, you need to have a very low latency and very high throughput. And so you are constrained to have a very good front haul. Now, what that means is that if you have fiber, you're okay. If you don't have fiber, what do you do? And there are different solutions. So one way to go is to have a wireless front haul that basically has the required characteristics, but doesn't require a wireline connection. So this is one way to go. The other way to go is to do a functional split, by which you only virtualize some of the functionality, and by doing so, the requirements on the front haul are more limited. So the front haul becomes more manageable. And again, it's a work in progress in the sense that on day one you might not have a fiber, you might have a more limited front haul capabilities, but then as the time goes by, you might eventually get fiber, and you might transition to a different model.
Now, have you seen actual deployments taking place without full fiber front haul, or not really?
Yeah, there is. Well, there are many trials with wireless and other technologies, or you have a functional split. KDDI has used a functional split. So even in Japan, where you think that there is fiber everywhere, it actually they don't have fiber to every single cell. So they do a functional split so that you have a centralized scheduler. So it's not it's not a vRAN, but we're moving there.
Okay, great. Renuka, what about you? What are you seeing in terms of actual trials and deployments?
Yeah, Martha, we are seeing some traction in terms of where the front haul requirements are less, as well as where the front haul requirements are at stake. So some of the deployments where you have that intermediate step, the functional split is such that you can do with lower, we can call it lower level for the front haul requirements. You have not only the radio head near the edge, but you also combine some of the PI functionality right there. So you keep your front haul requirements simple with that kind of a split. We are seeing those kind of deployments being asked for, and it's a simple step of taking the eNode B or the base station towards cloud, and also is easy on the front haul. On the other hand, there are deployments where they are looking for a complete virtualized remote function of base station, and that's where the front haul has to be basically the star in that whole equation, and has to meet the requirements for the LTE latency as well as the throughput bandwidth. Yes, those are being seen. We are seeing some traction in the leading on some of these early trials. And then slowly those intermediate steps are coming up in US. Some key operators in US are looking for a complete base station step and looking for how we can prove that the solution works for base stations, not only for the EPC or network side of things. Calling it a cloud architecture, I would say slightly easier.
Okay, great. And in terms of how this architecture is being used, are you seeing it a lot to support Hetnet type deployments, Renuka?
Absolutely, yeah. So the network now onwards is going to be a Hetnet, and that means that each type or variation of the base station has its own place here in terms of how you completely provide the coverage and also address the data growth problem. So yes, Hetnet is there. It includes the small cells of various types, where you have residential coverage with the indoor boxes, as well as you have the Wi-Fi pattern joining in, and then you move outward, and the macro base stations are now augmented with the picocells or the metro base stations which are deployed outdoors. So that Hetnet again benefits from how this cloud or the centralized architecture is going to work. The fact that you are bringing multiple base station units into consolidation with this architecture gives you a lot more flexibility to address the Hetnet related issue called the interference, for example, or aggregation of bandwidth, for example. Those are seeing new ideas because you have this consolidated architecture addressing the concerns typically which were coming in when, for example, you do signaling over X2 between different base stations or small cells. The centralized architecture or the cloud architecture is making it much more easier to handle those scenarios. And some features are very complex, being an example of POM, and very complex for the reason that it involves scheduling, it involves how the PI and the MAC can be coordinated across base stations. Again, bringing the base station resources into a centralized location that gives an advantage for implementing such complex features. So yes, Hetnet, and yes, cloud, they go into the ring in our opinion.
Okay, great. Monica, what about you? Are you seeing a lot of applicability to this architecture to heterogeneous networks?
Mm-hmm. Yeah, well, it really is a win-win situation. And in fact, I started working on vRAN from the Hetnet point of view because it really solves a problem. So as Renuka was saying, and this is really crucial because for small cells right now and Hetnets are not being deployed as fast as we thought it could because there are a lot of issues with interference. So vRAN is going to address that. So the availability of vRAN and a commercial to push and accelerate the deployment of Hetnets. And at the same time, the fact that the Hetnets, the need to have Hetnets, the need to have small cells is going to push operators to move to vRAN type of deployment. So I think that the two of them reinforce each other in a very nice way. So so especially in the short term, they're beneficial to each other.
Okay, all right, great. Monica, anything else on this topic? I know you've looked at it quite a lot.
Well, I think that it's really fascinating if you really take, as we were saying at the beginning, sort of the big view in terms of not looking at a specific model, but at the general opportunity that it opens. And I think that especially what this does is moves the RAN towards the core and the core towards the RAN. So we often think of virtualization as a move towards centralization, towards putting everything in a big data center. But I think that what this is really doing is to make us think of a way to organize the network where some of the functions are more centralized and some of the functions are more distributed. And what it does, it sort of blurs the line between what is core and what is RAN. And I think that this is really interesting because it opens the way to optimize the network in a much better way.
So what's more distributed, the radios?
Well, no, it's some of the processing. For instance, caching, some of the data traffic management can be pushed to the edge. Everything that it's where latency is important can go more to the edge, and then some of the processing can be more centralized.
Okay. Okay, great. Renuka, do you have anything else before we finish?
Yeah, Martha, I would summarize in saying that yes, we are very excited about this shift of the network towards Cloud RAN, and the eNodeB or the base stations are a crucial part of it. So we are bringing our products into the market and trying to help solve this problem and help get the Hetnet view of the network. So yes, Cloud RAN vision is what we believe in.
Okay, great. Renuka Bhalerao, Senior Product Manager at Radisys. Thanks very much for being here.
Thank you, Martha. Thanks, Monica.
And Monica Paolini, founder of Senza Fili Consulting. Thank you, Monica, for your time today.
Thanks, Monica. It was a pleasure being with you.